Space travel has always been a topic of fascination for humans. From landing on the moon to exploring the vastness of our solar system, we have always been curious about what's out there. But with traditional propulsion systems being limited by the laws of physics, is there another way we can travel through space? Well, yeah, we could use electricity, right? Let's dive in and find out if that is possible and if it's even worth it. Let's face it, space travel can be a bit boring. You're stuck in a tiny capsule hurtling through the darkness, with nothing to do but stare out the window and try to avoid getting space sick. But what if I told you that we could make space travel a little bit more interesting? With electricity? Yes, you heard me right. Electric propulsion is a real thing, and it's been used in space for decades. And let's be honest, anything with the word electric in it sounds way cooler than a plain old chemical rocket. Imagine you're a scientist at NASA in the 1960s, working on a project called CERT-1. You're trying to come up with a way to make rockets more efficient, when suddenly someone suggests using an ion engine. An ion what, you ask? An ion engine, they repeat. It uses electricity to accelerate ions and create thrust. It's the future. And just like that, the first ion engine is born. It's like something out of a sci-fi movie. Instead of blasting off into space with a fiery explosion, you're quietly propelled forward by tiny charged particles. It's like driving a Tesla instead of a muscle car. Sure, it may not be as flashy, but it's much more efficient. But let's not forget the downside of electric propulsion. Sure, it may be more efficient and reliable, but it's also not as powerful. It's like trying to race a snail against a cheetah. Sure, the snail may have more endurance, but it's not going to win any speed records. And if you thought electric cars had a hard time with hills, imagine trying to launch a spacecraft into orbit with electric propulsion. You might as well just attach a kite to it and hope for the best. But despite its limitations, electric propulsion is still an important part of space travel. It's like the nerdy kid in school who may not be the most popular, but is still an important member of the team. And who knows, maybe one day we'll come up with a way to make electric propulsion even more powerful, like strapping a rocket to a lightning bolt. Electric propulsion systems use electricity to ionize a propellant and create thrust. Unlike traditional chemical rockets that rely on burning fuel to create thrust, electric propulsion systems use electricity to accelerate ions and propel the spacecraft. So basically it's like a fancy electric car in space? Well, something like that. There are several types of electric propulsion systems, but they all rely on the same basic principle. Electric propulsion has several advantages over traditional propulsion systems. For one, it is much more efficient, meaning that it can use less propellant to achieve the same amount of thrust. This means that spacecraft can carry more payload and travel further distances. Sounds good, right? So what does the future hold for electric propulsion? Well, there are several exciting developments in electric propulsion technology that could revolutionize space travel. For example, researchers are developing new ion engines that use plasma to create even more efficient propulsion. There are also plans for solar sail technology that uses the pressure of sunlight to propel spacecraft. Imagine what we could achieve with this kind of stuff. We could fly around pretty much infinitely in our solar system. So what are all the possible ways to use electricity for thrust? Well, there are a total of 5 different electric propulsion systems for spacecraft. First up, we have the ion engine. As we mentioned earlier, this little guy uses electricity to accelerate ions and produce thrust. It's like having your own personal army of charged particles pushing you forward. It may not be the strongest, but it's definitely the most efficient. Next, we have the Hall thruster. This one's like the cooler, older sibling of the ion engine. It still uses electricity to accelerate particles, but it also has a magnetic field that helps to focus and direct the thrust. It's like having a jet engine and a magnet had a baby, and that baby was really good at pushing you through space. And let's not forget about the plasma engine. This one's like the eccentric artist of the electric propulsion world. It uses a magnetic field to heat up gas until it becomes a plasma, which is then expelled out the back of the engine to create thrust. It's like taking a flamethrower to your rocket, but in a good way. But wait, there's more. We also have the pulsed plasma thruster, which is like the crazy uncle of the electric propulsion family. It creates plasma bursts by ionizing gas and then quickly deionizing it, which creates a burst of energy that propels the spacecraft forward. It's like a series of tiny explosions that somehow manage to not blow everything up. And finally, we have the electromagnetic propulsion system. This one's like the mad scientist of the group. It uses electromagnets to create a magnetic field that interacts with the magnetic field of the Earth, creating a force that propels the spacecraft forward. It's like having a giant invisible slingshot that's always pointing in the right direction. So in conclusion, the answer is yes. We can use electricity to travel in space, but we cannot use it to take off from Earth yet. If this kind of technology advances enough, then humanity could explore space much further than ever before. By the way, if you are interested in how SpaceX managed to build world's first reusable heavy rocket, then check out this next video. Have fun, and see you in the next one.